All right, so now we are going to be putting triangles on the coordinate plane. So I can put a point right here. Okay, so say that's the point 512. I'm making it up, who knows? Okay, so 512, I put the point there, so say an angle measures right there. This angle measure here would be theta, okay? And we can make this a right triangle with the x-axis. So that's handy, okay? So this side would be 5 because that's the x value here. And how high up we went, that would be that side there. And we have this beautiful triangle with all the qualities, and we can use SOHCAHTOA. So that's what it's all about, SOHCAHTOA. But the problem is, you may be asking yourself, I cannot put a triangle or create a right triangle that has an angle of 120 degrees because all of the angles add up to 180 degrees in a triangle. So every triangle is 180 degrees. So how do I get a right triangle with 120 degrees? So how do I go, say, over here and create a right triangle? Well, I'll tell you what we do. We're just like, hey, bam, create the right triangle with the other x-axis. So when we create right triangles, we can put a point here. So say this is negative 512. Okay. And then we could put a point here, negative 5, negative 12. And in essence, we're creating the same triangle because distance isn't negative, right? So this distance here is still 5. And this distance here is still 12. Okay? But because they're in different quadrants, they're going to have different values. That's so interesting. I know you're just flabbergasted. And the angle theta is always going to be the same here. So this creates, in essence, a nice a circle, okay, where because it's 360 degrees, this whole coordinate plane, we can create 4 of the exact same triangles, but they represent, and we know because their terminal sides will represent a different angle. So for example, this angle right here might say be 120. So the angle in here would be 60. Okay? This isn't what they are, but I'm giving you an example. But it's 60 all the way around. So this could be 60. And so the angles are all the same. The triangles are all the same. But the sine, cosine, and sine and cosine and tangent will all be different because of the fact that they are in a different quadrant and they're negative or positive depending on what quadrant they're in. Isn't that fascinating? It's fascinating. So if we look at this triangle right here, that was great. It's just such poor drawing. Anyway, so this 5 is negative here. Okay, so then if I were to say do the cosine of that angle, whatever that angle is, the cosine would be adjacent, which would be negative 5 over the hypotenuse. Hypotenuse, 512, I think it's 512, 13. I would do the Pythagorean theorem, and this side would be 13. Yeah. 144 plus 25 is 169, which is 13. Okay, so this one would be negative. So the cosine of that angle would be negative 5 over 13. But the cosine of this angle here would be positive 5 over 13, right? Over here, the cosine would be negative 5 again, negative 5 over 13. And the cosine over here, this is now positive 5 over 13 because the hypotenuse is always positive because it's the hypotenuse. Okay, so what you'll see here is each of those angles have the same trig ratio, so 5 over 13 for the cosine. But because of the quadrant that they're in, they have a different sign. And that is the beauty of doing things on this coordinate plane. These angles that are formed with the x-axis are called reference angles. Okay, they're called reference angles, and we're going to discuss those a bit later. But they're an angle that's created using the terminating side of the standard angle. So that standard angle that goes all the way around, or in quadrant 1, 2, 3, or 4. But it's created with the x-axis, so it's always can create a right triangle in any quadrant. It's a beautiful thing. Okay? Wonderful. So because of this amazing feature, it creates a regular values for sine, cosine, and tangent. Okay, so cosine is positive. Okay, so which quadrants is the cosine of an angle positive? The cosine of an angle is positive down here and up here. So wherever the x value is positive, so wherever x is positive, cosine is positive. And it's very, it's interesting, and you can start to realize that x, I wrote it very poorly, so I'm just going to pretend like I didn't. X is always going to be associated with the cosine because that's the adjacent side of whatever angle is formed. So remember, adjacent side is is always between the angle and the right angle. So that adjacent side will always be the x value. So when the x value is positive in quadrants 1, right, and 4, so that's where x is positive. The cosine is also positive, and so is its reciprocal. As we all know, secant is the reciprocal. So where is tangent positive? Well, tangent is positive where both the opposite and the adjacent have the same sign. Okay, so that would be in quadrant 1 and quadrant 3. Okay, because when we do this, when we draw a triangle here, if this point here is 5 over, it doesn't really matter, 5 over 4, whatever. Okay, then this is 5 for the x and 4 for the y. This is theta. Then tangent of an angle, remember, is opposite over adjacent. So both of those are positive, it's going to be positive. But then both of those are negative. So if we have negative over negative, so negative 5, negative 4, we have the same triangle, but negative over negative is a positive. So where they're both the same sign, tangent is positive. So that's tangent and cotangent. Which quadrant is sine positive? Well, the other one, quadrant 2. Okay, so wherever y is positive, because sine is this upper one here, right? Sine is always the opposite angle, or the opposite side. So I'm trying to, sorry, I can't erase that now. It's over. Okay, so if I draw a point here, so say this is negative 5, positive 4, that means the x was 5 or negative 5 and the height was 4. So since theta is here and this is opposite and hypotenuse, this one would be the hypotenuse. Those are both positive in quadrant 2, so is sine, and also quadrant 1. So notice that all of them are positive in quadrant 1. That's interesting, right? And the reciprocal of sine is cosecant. Okay, how will we use this information? We'll find out tomorrow. But one way that we use it, and it was supposed to be in that little triangle, but in that little coordinate plane, but I wrote over it, and now I can't erase it. So what we learned here, it was that everything or all things are positive in quadrant 1. We learned that sine and its reciprocal secant, or cosecant, is positive in quadrant 2. Tangent and cotangent are positive in quadrant 3. And cosine and cosecant are positive in quadrant 4. So we create an acronym. All students take calculus. Your friends might have other things, but it goes in a C, just like the quadrants do. all students take calculus, all sine, tangent, cosine. All right, and that tells you which ratios are positive in that quadrant. Okay, have a good day.